Good morning. Oh, it's on. Excellent. Hi, thanks for coming. My name's Dale. I'm a developer for IBM, and for the last 4 and a bit years, I've been a developer of a system called IBM Watson. I've called this talk Bringing IBM Watson to the Cloud. What I want to talk about is how we make Watson available. How Watson has turned into the system that did one job, that played the game show, into a system that is now doing a number of different roles, being trained in a number of different industries and domains, and doing jobs for different types of businesses and groups. So I want to walk you through an example of one way that the system can be trained. Before that, to try and make sense of why the system needs to be trained the way it is, I want to explain a bit about how it works. But first, I want to start by explaining why we're doing this at all, why we're doing what we're doing. IBM's been working in this field of question answering for a very long time. Research and development for many, many years in this field of getting a computer to understand and answer our questions. And in 2011, I wouldn't say we'd finished. I wouldn't say we finished now, but we'd made a number of breakthroughs in key areas, and we felt ready to demonstrate the progress that we'd made. So we entered it onto this TV quiz show in the States called Jeopardy. The point of it was an example. The point of it was to explain, to make it clear why we're doing what we're doing, and to show the progress we'd made in an accessible way. But like I say, that was 2011, and it was the result of a lot of work. And it's worth explaining why we're doing this, why we think there's a need for question answering systems. And we think there is because, as the amount of text and documents in the world continues to increase, and as the questions we want to ask get more and more complex, we think there's a need that isn't being addressed by existing technologies, by search and other such strategies. I want to show you what I mean by that with an example. Which English Grade 2 listed building from the 1860s started life as the location of shows for the Royal Smithfield Club and later the British Army's Rule Tournament, now used as an exhibition hall and conference centre, as well as providing offices for a large number of companies? It's early, but anyone? It's not supposed to be a trick question. It's where we are now, the Business Design Centre, or more accurately, the Royal Agricultural Hall that hosts it. So imagine that was my question. I put it into a search engine, and my top result is a page about Bletchley. It hasn't got, not only has it not got the right answer, but it's not understood what it is I'm asking. Because search isn't trying to understand my question. It's not trying to answer my question. What it's doing is it's finding me documents that contain words from my question. I had now, because it's now used as an exhibition hall. So I get that document because the word now is in there. I had the word large for a large number of companies. I get that document because it's got the light had a large shade. And it's not just the top result. If I go for the next few, no idea what that's about. If I go through pages and pages of answers, there is nothing about this building, nothing about this place here. This is why we think there's a need for this kind of thing. We think there's a need for systems that can understand what it is we're asking and use an understanding of our questions, an understanding of the documents where it's going to go and look for answers to help us answer our questions. So with that, when I say we think there's a need for a system that can understand our questions, what I mean is we think there's a need for a system that can reply like this. Not hundreds of thousands or millions of documents, but specific answers to specific questions, each one with evidence that has been evaluated and weighed up and used to come up with a confidence level in how likely that is to be correct. If you were here early enough to see the clip I was playing from Jeopardy, or if you've seen the Jeopardy show before when Watson entered, that's what you're watching. That's what you're seeing, specific answers to complex questions with a level of confidence associated with each. Even if you look at the wrong answers here, I've not looked in detail into all of them, but they're all names of buildings, probably all Grade 2 buildings, or at least some sort of listed building. They all probably have some connection with businesses or conferences or something like that. These are answers based on an understanding of the question that I asked. So I said that before I sort of show you how we train it, I wanted to explain briefly how it works, what's going on when Watson's answering a question. It starts from documents. It starts from this isn't a lookup engine. This isn't a knowledge base. This isn't a lookup structured table or rows or database or anything like that. Watson's knowledge comes from documents. Now, to do the quiz show, that was newspapers and magazines and encyclopedias and dictionaries and books. And it's a Hadoop cluster running a variety of NLP jobs, going through the documents and trying to extract usable knowledge from them. It's picking out the things mentioned in the documents. It's picking out the relationships between those things. And using a wide variety of strategies to do that under the covers. It's using some linguistic approaches, parsing the text and looking for relationships that are described in the text. It's using statistical approaches, keeping track of how frequently things are mentioned in close proximity to other things, and using that to infer relationships. As well as using sort of more semantic means, like where some of what Watson reads can be web pages. And web links are another way to infer relationships between things. And that knowledge that's extracted from those documents is what's used when Watson is trying to answer a question. We call this the pipeline, this idea of a question coming in one end, working its way through the system, and what comes out the other end are the answers that I've been showing you. So I'm going to quickly rattle through this to give you an idea of the sort of approach Watson's taking to answer a question. And to illustrate this example, I've got a simple trivia question. Which US president assassinated in Dallas in 1963? So the first thing we want to do, Watson's going to try and work out what this question means. Before we try and answer it, we want to make sure we understand what this is asking. And similar to before, we use a very large number of strategies to do this. We will take the question as a whole. We will look at each individual word. For example, even just the first word, the question word. If that's when, I'm being asked for a time or a date. If it's where, I'm being asked for a place. If it's, in this case, it's which, I'm being asked for a thing or a name of a thing. But all the words in there, like Dallas, capital letter, it's got in before it, it's probably a name of a place. There's the reference to the US, probably a place in the States. 1963, recognizing that this, in the context of the sentence, is probably talking about a date, a year. Because that understanding means that we stand a chance of finding the answer in a document that talks about the 60s and never actually mentions 1963. So we come up with our interpretation of what the question means, but English is ambiguous. We will come up with more than one idea. I mean, maybe not for a question as simple as this, but normally for complex questions, there's several ways you could try and unpack it, several ways you could interpret it. Partly that's because, like I say, English is ambiguous, but also just because there might be more than one way of looking at the question. So say, for example, say we gave Watson a document to read that talked about Albert Einstein and how he won a Nobel Prize for a paper that he published. The sorts of relationships Watson will be picking out of that as it goes through the text is that scientists publish papers, that scientists win Nobel Prizes, and that Nobel Prizes are associated with subjects and so on. So imagine you had a question of who won a Nobel Prize, who won his only Nobel Prize in 1921. Well, one interpretation of the question is going to be saying, we're looking for a scientist, because I've seen loads of relationships in the documents that I've read that it's scientists who win Nobel Prizes. But another interpretation of the question might be saying, politicians can win Nobel Prizes for peace, so we might be looking for a politician. So there's going to be another interpretation that's going to start addressing, tackling this question with an interpretation of we're after a politician. Another one might be saying we're looking for a poet, because you can win Nobel Prizes for literature, and so on. And when we don't just keep track of all the relationships we see, we keep track of how often they come up. So, if we've given Watson a ton of documents to read that most of the time talk about Nobel Prizes in the context of science, then Watson will have more confidence in its interpretation of the question that we're after a scientist here, and maybe a low level of confidence that it's after a politician. So, several interpretations of the question. And from this point on, we're in parallel. We want to do this quickly, so I'm going to pick one and go through it. So, for each interpretation of the question, we need to do a search. We need to go looking through our corpus of documents. Now, in the quiz show days, that meant 500 gigs of text. And like I say, that covered encyclopedias and dictionaries and the complete works of Shakespeare and back issues of newspapers and magazines. Now, we're using a very large number of strategies and search technologies here. Some of this search is structured. We're going to be turning our interpretation of the question into Sparkle queries, for example. Some of these search strategies are unstructured. So we're going to be turning our interpretation of the question into Lucene queries. Everything from short keyword type queries to long, complex, weighted, phrased queries. We're going to be turning it into Indri queries and many more besides. And like I mentioned, we're going to be using our understanding of the question to try synonyms out. So, where I've got my question about 1963, hopefully I'll be generating some search queries that mention 1960s, the early 60s, and so on. And what we're pulling back are documents and articles and passages. For each search query we generate, we're going to pull back the top 100 search results. So we're going to be pulling back things like an article on US presidential history. Now, we don't just want to return you lists of documents, we want to give you specific answers. So we're going to pick out all the things from that document that look like they could be an answer. Now, we're going to hopefully pick out the right answer, and other presidents who were assassinated like Garfield and Lincoln. But at this point, in machine learning terms, we favor recall over precision. By that I mean we set the bar really low because we don't want to risk throwing away the right answer. So we want to make sure we get the right answer, we tolerate a load of wrong answers. So we will pick out probably names like Clinton and Reagan just because they're names of presidents. They could be answers to a question. So, a few interpretations of the question. For each interpretation, several types of search. For each search, 100 results. For each result, maybe a dozen or so answers. So for each answer, the next phase is to look for evidence. So for each answer, like Abraham Lincoln was one of the answers I picked out, we're going to go back to that corpus of documents and look, and again, use a variety of search strategies to generate search queries to pull back information about Lincoln in the context of this question. And what I'm looking for are documents and articles and passages, evidence that will show me this is the right answer, or in this case, evidence that will show me this isn't the right answer and I can eliminate it. So the kinds of things I'm going to be pulling back are a biography about Lincoln. So for each piece of evidence, the next phase is to interpret it, to work out what this evidence is telling us. We have a very large number of, at the moment we're up to like sort of 400 and something, stateless bits of code that look at the piece of evidence from a particular perspective. Feature score, as we call them. And each one is going to sort of look at this and see, does this tell us this is the right answer or not? And like I say, from a very particular way of looking at it. So there's going to be a bunch of scores in there that are what I would describe as lexical. By which I mean we're saying we know from the interpretation of the question that we're looking for a name of a US president. Does this piece of evidence tell us Abraham Lincoln is a good answer for a name of a US president? So they should come up with positive scores because those scorers will find references to him being elected president. Some of those 400 scorers will be spatial, looking at geography and places. And they're going to be saying, well, we're looking for someone from the United States. We're looking for someone with a strong connection to Dallas. They will look at this biography and hopefully find references to him being born in the States, lived in the States, elected president of the States. I don't know if Lincoln has any connection with Dallas, but one way or another, I would expect the spatial scorers to come up with broadly positive scores as well. There's also going to be a bunch of scorers in there that are temporal, that are looking at times and dates, and they're going to say, we know from the analysis of this question that we're looking for someone who was assassinated in the 1960s. Now, ideally, they'll find when he died, and they'll be able to know that this isn't a good answer. But even if they don't, all of the dates are in this document are going to be in the 1800s. So one way or another, I would hope that the temporal scorers would come up with negative scores. Like I say, 450 or so of these scorers. And if you remember how this is fanned out, for each interpretation of the question, loads of searches, for each search 100 results, for each result a dozen answers, for each answer several evidence searches, pulling back hundreds of pieces of evidence, and for each piece of evidence 400 or so scores. By this point, millions and millions and millions of scores that need to be merged and collated and ranked. And we do this through machine learning. Because we're throwing all of Watson's strategies at every question, at every answer, at every piece of evidence. But they're not all equal. Some strategies are going to be brilliant at some pieces of evidence. There are going to be some strategies that are brilliant at evaluating evidence for a where question when the evidence has come from a press release. There's going to be some scorers that are brilliant at looking at research papers. There are going to be some scorers that are brilliant at answering procedural questions where the evidence has come from, I don't know, a brochure or something. So with enough examples of questions with the right answer, Watson learns how to weight these scores. It learns when to lean on some strategies and when to lean on others, both in terms of where the answer has come from, but also what types of questions. So it will tackle different questions in different ways from what it has learned, from what it has experienced during its training. And those scores being merged and collated is what comes up with those confidences that you see associated with each answer and how we work out not only what we think the right answer is, but how likely that answer is to be correct. And if you saw the quiz show, we need to do all of that end-to-end in, 2-3 seconds to be able to buzz in time. Now, if you've seen what we've been doing with Watson since, it's probably in the context of one of the healthcare projects. These seems to be the ones that are getting the most press. And I can see why, because they are amazing projects. And I'm very proud of what we're doing, and I'm very proud to have been able to work on some of these, because I do think these are going to change the way we do healthcare. instead of giving it text, like encyclopedias and newspapers, it's about giving it treatment guidelines and medical research papers and medical journals and so on. And the questions, instead of being trivia, are, given this medical record, what's the right treatment or what's the right test for this patient? And this is being used now, albeit still in early phases, in over a dozen hospitals in the States. And I could go through what this looks like and give you a demo of this, but I figured, you're a development crowd, and, these are projects that we're building, that, taking this architecture, taking this technology, over several years, working closely with oncologists, we're able to build this kind of thing. But I want to show you the kind of thing that you guys could build, sort of starting at the other end of the spectrum, to give you a bit more tangible feeling for what we can do with this. So instead, I want to demo this. Is everyone familiar with the retailer North Face? Sort of nods, brilliant. So they're a retailer who sell camping and hiking and trekking stuff. And if you go into one of their stores, you can sort of say the trip you're planning. You can tell the assistant there, I'm going to this kind of place, I'm going to do these kinds of activities, what do I need? And they will give you the advice to help you plan your kit. But if you go to the website, you don't normally get that kind of expertise. You don't get that kind of support. And if they have a search kind of thing, and you say, well, I'm gearing up for a 14-day backpacking trip, what do I need? I talked about the limitations of search as a strategy. Imagine they have a page on their website about what you need for 2 days, or 3 days, or 7 days. It's got the word day in there, so that will probably come back. Or what if they have the perfect answer that says, this is what you need for a fortnight, or this is what you need for a couple of weeks? I didn't use any of those words, so I probably won't get that. What we want is a system that's going to understand my question and understand the documents that this system has read and use that to come up with an answer specific to me. So what we give them is an API. They submit the question, and what they get back is a response with the answer that, in this case, simple start, you need a tent and a sleeping bag and a technical pack. And they've made this look very pretty. But this isn't a quiz show anymore. You can ask a follow-up question. So maybe you say, well, I'm going to this particular place, and I'm going at this time of year. So let's start with technical packs. What technical pack do I need? And again, they've made the response from the Watson platform look quite pretty. But still, it's about presenting a list of answers that were supported by evidence. So, these are the technical packs. Based on what Watson has, the knowledge Watson has extracted from the documents this system has read, it thinks these are the best fit from what I've described so far. And maybe, I see terms I don't recognize, like there's that reference to ABS, that red backpack at the bottom, and I don't know what ABS means. So I can ask, can you tell me a bit more about ABS? Now, if this returns me a bunch of documents about anti-lock brakes, it's missed the context of this conversation. Because what I'm asking about is this idea of an avalanche airbag system where you pull the thing and the airbag comes around you. Specific answer to my question in the context of this conversation. Now, I mentioned that the way we come up with answers and the way we come up with our confidence in the answers is by scoring pieces of evidence. Now, sometimes users want to see that evidence. They don't just want a final answer, take it or leave it. They want to know why this pack was recommended. Now, this isn't a system that's read Wikipedia and Time magazine. This is a system that's read information about all the products North Face sells, but also, magazines, reviews, blogs, enthusiast sites, and so on. And that's where Watson will be getting its evidence from. So it can show that and can say, well, from an understanding of these particular customer reviews and articles and posts, and from an understanding of what you've described of your trip so far, this looks like the best fit for you. This is the kind of thing that I mean when I say that we want to go beyond search. We want detailed question answering based on an understanding. So I want to show you how we train this kind of thing. I've tried to come up with an example that's a little bit topical, so I've gone for Wimbledon, as that starts soon. Are there any tennis fans in? No, I've lost you all, never mind. So there isn't one Watson system that is becoming an expert in every subject under the sun. Watson is an architecture that we can use to build these kinds of question-answering systems. So the idea is that you get your own instance of Watson to train. And I'm going to skip past the bit where you have to provide it documents. So, this is software as a service. This is cloud-hosted stuff. This is web-hosted tooling where you will go and you will upload your PDFs and your web pages and your Word documents and your text files. So, I mentioned North Face. That would be them uploading the information about the products they sell, them uploading the reviews and the magazines and so on. But for Wimbledon, this might be all the annuals and programs. In fact, that's what I did for this quick demo. I uploaded a load of annuals and programs from previous tournaments. And what you also need to do is gather examples of questions that you want to train the system with. So what are the kinds of questions you're having to answer now? Can you grab together a collection of them, because we're going to use them to teach Watson how to do this job. So skipping past that, I'm going to log in. And the first thing you'll see is that the system's going to look at the questions I've provided, and look at the documents I've provided, and pick a subset of the questions that it's going to ask me to train first. It's going to look and see. You see that introduction task at the top. It's saying that these are the questions that we think will get us going fastest enough, because we want to make the best use of your time teaching Watson, training Watson. So if you click on Start in that top corner, we're going to show you one of the questions, and our best 4 guesses at the answer for now. So this is an untrained system that has no idea which of its strategies are good and which of its strategies are going to be bad, because it's had no examples, it's had no training. But it's going to take its best stab, and it's going to ask you to rate out of sort of 5 stars what you think of each of the answers it's come up with. And as you rate each answer, once you've rated all 4, you can click Submit, and it will take you to the next question. And you can sort of see that it's picked you a task of 50 questions to get you started, because that's a good kickoff. So you get another question, another set of answers. You go through and rate. Well, that one's not a great answer, but it's sort of still talking about ball boys. Fair enough, 3 stars. Once you've rated them all, you hit Submit. And the kinds of things you're teaching it is, do you want shorter answers for some types of questions? Well, when you tick 5 stars for the shorter answers, Watson's learning that the kinds of strategies that it uses to pick out a short answer from a document, those are the ones to rely on. Or if you prefer longer, detailed answers, when you hit 5 stars on a long, detailed answer like that one in the bottom right, you're training Watson that that's how you want it to answer the question. As well as training it, for example, what kinds of documents are useful at what kinds of questions. Going back to the task screen, so you don't have to watch me train all 50, you can sort of see, well, I've made a little bit of progress there, and I can carry on. And there are different ways we ask you to do ratings, partly because different ways of collecting information is useful and valuable, but also, to keep it a little bit interesting. So we can show you 4. Sometimes we'll just show you 1 answer and ask you to rate that. But the same kind of idea. We're using the current trained state of the system and asking you to give us feedback, because that feedback is how Watson learns. Watson learns from experiences, and that's how it learns how to use its strategies and when to trust its strategies. But let's say, we skip forward a bit. So imagine I've completed that introduction task. I've done a bit of work. I've gone through this 100 questions. And what you'll see is, it's now generated me a new task. As I finish tasks, it will keep generating me new ones to keep my training going. And there are different reasons it will pick some. It's noticed, for example, the top left one, it runs all the questions through a classifier. It tries to guess the topic for every question. And if it sees any particularly large topics, it might generate me a task to train in that topic. It's saying, you seem to get loads of questions on this particular topic. Train me how to handle those. But at this point, the system still hasn't had a great deal of training, so maybe it's getting a lot wrong. Maybe I keep rating 1 stars or 2 stars. So if it sees that, because although that's useful feedback, we need some positive feedback as well. We need not only to learn what doesn't work, we need to learn what does work. So you see that task in the bottom left there, search. What it's saying is you're doing a lot of rating of answers with only 1 or 2 stars. So I'm going to show you those questions again, but this time, can you show me where the right answer is? So if I click on Start on Search, actually, sorry, skipping that bit. If I go to Search, it's just going to show me the question and give me a search box. And, me as a subject matter expert, I know the keywords, or I know the document name, or I know where the answer is, and I can jump straight to it by putting in the right keyword, and then sort of say that is the perfect answer to that question. Now, this takes a bit longer, so we don't want you to have to do that too often. So as long as the answers Watson is suggesting are good enough, and you're rating them as 4s or 5s and so on, you won't have to do too many searches. But if you are getting in a place where the answers aren't great, we'll give you some search tasks to get you back on track. But say that continues, so I'm skipping forward again. So I've done loads of tasks. And you can sort of see if I scroll down, all the tasks that I finished. So Watson's getting better. But still, we're trying to choose questions for you to rate to make the best use of your time. So you see in the top left, we're using sort of active learning strategies, by which I mean identifying the questions that are going to have the biggest impact on Watson's models. Identifying the questions that are going to train Watson the fastest, because we want to make the best use of your time, and we want you to get the system trained as quickly as possible. And in the background, once you have trained a certain number of questions, we're going to start running tests. It's like setting Watson an exam. We're going to pick a subset of the questions and ask Watson them without giving it the answer and see how well it's doing. And we're going to use the test results to generate new tasks. So we're going to pick the questions that Watson does really badly at and then get you to answer more questions, to rate and train more questions like that. But you don't need to know that. All you need to do is keep hitting start, keep hitting resume, keep going through the tasks until the performance is up there. But if you do want to see how the training's going, if you want to see the results that we're using to figure out what questions we want you to do next, you can. And you can see performance over time. You can see from the x-axis here, I didn't spend a massive amount of time getting this demo ready because it goes from 11 to 12:30. But this could span potentially days, maybe, or even weeks if you're spending a lot of time training a system in some depth. And then what you get at the end of that, having trained a system, so you've got your own isolated Watson system, you have uploaded your documents about whatever it is, subject matter that you want the system to be able to answer questions on, and you have trained it how you want it to answer questions and the kinds of answers you want it to come up with. What you've trained and what you've got at the end of that is a REST API, as I mentioned before. And if you're familiar with Swagger, that's how we do our API documentation. And what it is similar to what I was explaining as I went through the North Face demo is, you post a question and you get back the answer, but also information about the answer, like the evidence and where the answer came from and so on, if you want to show it in some context. And also using Watson's confidence that we return to help you decide whether or not you show the answer, or maybe if Watson isn't very confident that's the right answer, you ask the user to rephrase it or something like that. I want to quickly talk about getting started because you may have noticed our standout in the exhibition hall on Bluemix, which is our platform as a service. And there's a way to get started with the question answer API here. Now, this isn't about training it. This is a system that we've given some documents to read, just a small handful, and we've given a bit of training, again, just a small amount. But it's enough so you can try out the API. And you can see the API documentation that explains how the question answering works, but also sample code in a bunch of languages like Java and Node and Ruby and so on. So you can see what it's like to try and build something like the North Face app I showed you before, to see how much work is involved in integrating Watson into your app, your website, your phone app, your tablet app, or whatever. And then if you decide that you think it could be good, that it works, then you can talk to us about getting your own instance with your own documents and your own training. So in summary, I said I wanted to talk about bringing Watson to the cloud, how we've taken this idea of a research piece of technology that we demoed on a quiz show and making it available as a cloud-hosted thing that can be made available working in a large number of industries at once. And I've gone through the strategies that we have for training it and how we get you to get your subject matter experts to train the system, and then what that can look like in a final app. And with that, I've fortunately left time for hopefully some questions. Yes?
Is it possible to combine two training instances, say two completely different subjects, train two
So if people didn't hear, what about having more than one instance, on different subject matters? I don't know if anyone's done that, but that's certainly something we've talked about before, and maybe even to be a bit meta, a Watson of Watsons that decides which one to send the answer to. Yeah, I think that sort of thing could work. I can't, off the top of my head, I can't think of anyone who's doing that, but at the moment we've got hundreds of clients who are at some stage of training the system, so I've definitely lost track of what everyone's doing. So maybe someone is. Yes?
Does it pre-cache in topics? So, like you mentioned, sort of president of the US, that historic data isn't going to change.
Yep.
Abe Lincoln and what have you. So does it do anything like that?
So there's Watson as like a base architecture, and as we do for different use cases, we will have either different subsets of that or different stuff on top of that. So this idea of like FAQs or a question where the answer isn't going to change is good for some use cases. So we do have that. But it's not good for all use cases. Like I mentioned the healthcare kinds of systems. If I ask what's the right treatment for this illness, I don't want what's the most common treatment. I want what's the right treatment for this patient who is this old and has these allergies and is pregnant and what have you. So an FAQ sort of approach wouldn't be appropriate. But for something like a retail setting or a customer services setting, FAQ is absolutely a good approach. So we do have that. So yeah, it's an optional thing, and a lot of clients are using it. So yes. Yes, please.
What kind of technology do you use? Because you have lots of information and lots of relation between this information, and graphs make everything seems to be should be kept in memory in order to have
So the technologies we use, I should have covered this. Most of Watson is written in Java. I would say 3/4-ish is written in Java. The rest is mostly C++. Although actually, in the question analysis phase up here, there's a fair chunk, like 50,000 lines of Prolog or so in there. Now, the orchestration thing that moves stuff along from one phase to another and handles the distributing it is a technology called UIMA, UIMA, Unstructured Information Management Architecture. It's an Apache text analytics thing. So that moves the stuff across. In terms of how we're storing stuff, there's no one way. There's lots of different ways that different strategies are using. So, I mentioned, I think, before when I was going through the pipeline that we'll have, a wide variety of Lucene indexes, for example. For the more structured stuff, Sesame stores to be able to do Sparkle queries against. So really loads of different ways of doing it. But like you say, particularly in the quiz show days, but even to a certain extent now, speed was a big concern. Yes?
How about models, like when the users train the models? What kind of models are they training?
So it's essentially a sort of logistic regression model. It's a bit different, but that's the closest sort of easy analogy. To be clear, we're not trying to mimic the way the human brain works, so it's not a neural network or anything like that. It is about weighting the scores that we're getting. Which is nice. I sort of mentioned that. Can I go back? No. I mentioned that there's hundreds of scorers, and there's a lot of flexibility on that. There's almost no constraints on what those scores have to be. So some are producing Booleans, some are producing a true/false, some produce a score from 1 to 10, some produce percentages, and so on. So the kinds of things that the model is there for is partly to learn the range, the min and the max. Like what does a score of 8 mean? Is it 8 out of 10 or 8% or what have you? And it's through experience that Watson will say, this score has always produced numbers between 1 and 10, and now it's saying 12, so it must be really confident. But it's not just about the range, but the distribution. Some of the scorers are not at all linear. Some are going to be like almost always producing a 0 because they're looking for the weird edge cases, and they very occasionally fire with a 1. So the model is also there to recognize the significance of one firing. And also to recognize how good a scorer is. One of the first things we get any new developer in the team to do is to get them to add a new scorer that's a random number generator. Because it's producing scores that have absolutely no correlation with the right answer or evidence or anything. And at first, that might slightly dent, it's one signal out of 450, but it might dent the accuracy a bit. But in time, Watson will learn that there's no statistically significant correlation between those scores and the right answer. So those will be weighted essentially by multiplying them by 0, in terms of the net result. But yeah, so that's the general approach there. Yes? So for those who didn't hear, what happens if there's conflicting opinions in the documents? Is that what? Yeah. I guess that would come down to the training. So, Watson would learn which sources to trust over others. So an example I've used in the past is, what if you asked a Watson system, is climate change, is global warming, is it real, is it man-made? Now, firstly, it would come back to that first phase I said, where you're choosing the PDFs and the Word documents and the web pages to upload. So if you uploaded purely scientific literature that was saying, look at all the evidence for global warming, Watson's answer would be, yes, it's real, and it would say, here's all the evidence I found. But if you took that same technology, that same architecture, and you only uploaded skeptic, right-wing, the case against, Watson will say, nope, global warming's not real, I'm really confident, here's all the evidence I found. But like you say, what if you'd uploaded both? What if Watson's corpus was made up of documents covering both? And this would come down to the training, because the training is teaching Watson for some types of questions favor these kinds of documents. And if the system has been trained by scientists that are always, when they are shown a scientific question and they're shown answers from scientific and non-scientific documents, if they always choose answers from the scientific ones, Watson will learn that those are the sources to trust for those kinds of questions. And that, there are more subtle instances of that. I was helping a client last year who they wanted Watson to answer questions about the products and services that they sold and the projects that they work on and the clients that they work with. So they uploaded a corpus of everything from press releases and brochures to technical documentation, manuals and research papers. And then they started off on the training, but they got people who weren't really experts in their products or services. So they got people to do the training who really didn't understand the technical documents or the research papers. So these were people who were always rating the answers they understood from the press releases. So what they taught Watson was, whenever you get a question, the answer's in a press release. So their Watson system ended up speaking in marketing blurb. You know, it would pick bits out of press releases, no matter how technical the question. It was generally going to the press releases because it hadn't been shown examples of how to use a technical document. It hadn't been shown examples of using research papers. But more importantly, it had been shown that those can't be trusted. So then they came to us and said, well, why isn't Watson answering my technical questions very well? And, you know, looking at their training, we were able to say, it's because you need, you know, if you want Watson to answer technical questions, teach it how, give it examples. And that's similar to what you're saying, because they were sort of correct, the stuff it was picking out from the brochures, but it wasn't the answer they wanted, which was the more technical stuff. And Watson's way of learning which to use and which to pick comes from what it learns from training. Any other questions? Yes?
Can we add an extra feature extraction algorithm?
So technologically, absolutely. It's an entirely extensible platform, and you can insert not just new scorers, but new search strategies. So, for example, working on some of the oncology projects I mentioned before, one of the search strategies that was added to base Watson was this idea of, we were working with a cancer hospital called Memorial Sloan Kettering, and they've got a really cool system where you give it an image of a cell, and it works out what kind of cancer that's likely to be from an analysis of the image, which is a useful signal. So adding in a new search strategy here that knows how to pick out the cell picture from the medical record, sending it off to this third-party system, and what it gets back is a candidate answer that then gets evaluated in the rest of Watson's normal way. So we absolutely do extend it at every point. Now, I mentioned, you know, the tooling where we're providing, where it's not us building the Watson system, but we're providing it to people like yourselves to build your own. At the moment, we don't make that as extensible. It's a bit more locked down, and your input is the training. But that's just an initial point. You know, I'm sure we will get to the point where we will open up the ability to extend the pipeline to everyone in time. Any other questions? Yeah.
This has got sort of obvious applications for internet search and stuff like that. So how far off are you from having like just a all-purpose search engine?
We are still a long way from this idea of a system that can answer any question on any topic, mostly because scaling the training doesn't work. You know, even if I mentioned we're doing projects in healthcare, it's not even that we would say all of healthcare. I mentioned we're working on cancer. We don't even train Watson on all of cancer. We pick a niche. And that's partly because the sorts of people using these systems are deep subject matter experts. So there is a Watson system, for example, that has been ingesting documents and is being trained about heart and lung cancers. So, I mean, it comes because to make the models mature enough, you need to have walked through every route through the system. So you need examples of every type of question. You need examples of using every type of source in your corpus. You need examples of every type of scorer. And that's doable when you pick a niche. But it's difficult if you tried to say any question in the world. I think training would just be so time-consuming as to be unmanageable. But that's just the current state of the technology, and it certainly is advancing quickly. Yes.
That's a follow-up.
Yeah.
On Jeopardy, you had various topics. So how did Watson react to that?
I think it's easier to do breadth if the level of complexity is lower. You know, so it's the level of understanding needed to do something like the quiz show is a lot less than to answer questions from an oncologist asking about a heart cancer diagnosis. So I think, yeah, you can get away with breadth as long as it's shallow. And I guess that's why we're trying to do both. So if you look at the different approaches, we are spanning both the healthcare kinds of systems where it's deep subject matter expertise, acting as an assistant to doctors, but also about, systems like North Face or the kind of demo I put together for Wimbledon, this idea of asking questions from the public. Or, if you look at I mentioned we've got hundreds of clients who are training Watson in that kind of thing. The kinds of groups I mean are retailers, consumer electronics manufacturers, banks and insurance companies, an insurance company who can have a system that can answer questions like, am I covered for such and such? And having read all the policies that this company offers, can understand the question, can understand the policy and say, yes, you're covered or no, you're not. So those are the kinds of things people are training it for. So it still tends to be bound to a domain. Yeah.
Do most of your clients, like, presumably you can deploy Watson on-premise as well as people prefer either way?
There are very few clients doing it on-premise. There's a few reasons why, but let me find a screenshot of, where did I put it? When you, say you upload a load of documents, and then you click Create Corpus, in the background we're kicking off Java jobs with like 200 gig heaps. You probably don't want to, and it's really spiky, because once you've done that, you don't need to do so much afterwards. So I think the workload is well suited to cloud, because as long as not every client clicks Create Corpus at the same time, I wonder what would happen if they did. As long as not everyone does, then we can provision across all of them. And then, the runtime hardware requirements, which is much, much lower, it sort of balances out. So I don't think you would want to do it on-premise, and I'm not. And generally, we offer it through SoftLayer, which is our cloud offering.
Clients get twitchy about sensitive documents.
Sometimes, not so much about putting it in the cloud at all, but sometimes they do want us to be able to show them where it's going to live. Is it going to be in an instance in the States or in the EU or the UK? So to be able to show that is important. But yeah, there are still going to be some clients who, even if we can say it's going to be within the UK, that's still not enough for them, and maybe this wouldn't be the best fit today. Any other questions? Yes. Yeah, so I showed the Swagger doc briefly, but there is an API for feedback. Now, different clients have exposed this in different ways. The most common way I see it is just next to the answer to put a thumbs up and thumbs down button and get the user to at least say this was helpful, this wasn't helpful. And if they provide that, that goes into the same kind of training that you'll be doing. So yes, the idea is that it should get smarter the longer you use it. It should improve with use. Yeah, so there is a way of having user feedback go off into a separate staging area which you can review before you apply it, assuming that users are users. And it's been interesting because we started off, for the first couple of years, it was mostly healthcare projects. So it was, oncologists, very serious people doing very serious jobs, asking Watson very serious questions. And then we started doing these projects where we were putting it on the internet. You've got companies like USAA who have it on their website now that can answer questions about, they do support for military veterans leaving service. And yeah, you start putting these systems, and you frame it by saying this is a system that has read documents about this, and it's been trained about that. And then people ask it questions like, will you marry me? Which is one of the most commonly asked questions on a lot of the systems I've worked on. And in fact, that is how we handle those kinds of questions. Not so much the really mad ones, because then we have low confidence. We know we can just say, sorry, I don't know how to answer those kinds of questions. But the more interesting ones were when people started, like, someone would ask a question, we'd give them the answer, and then they would say thank you. And then Watson would try to answer thank you, treating everything it gets as a question. So what we've done in the last year or so is try to add in that sort of conversational framework stuff, recognizing that thank you isn't a question, and just to say you're welcome. So even in those kinds of things, Watson is getting smarter. Any other questions? Excellent. Well, I'm going to be around for a bit, so if you think of anything, please do sort of come and find me. I'll probably be hanging around the IBM stand out in the hall. But otherwise, thank you very much for listening. Enjoy the rest of your day.